Okay, so here's the answer key for 8.6 homework. Very similar to the notes, right? I mean, this obviously has more problems than the notes, but if you see two exponential expressions or two powers with the same base and just one on each side, right? Then you can assume the exponents have to be the same. So that's why 2m minus 5 equals 4 minus 3. Solve for m, easy to get -1. For 2, the powers are not the same, but you force the issue, make them the same. 64 is 4 to the 3 power. But since 1 over 64, make it 4 to -3. Now I can compare the exponents correctly, and we're good, right? And solve it like you would any quadratic equation or any equation, and you're fine. For log equations, if you have to combine logs, do it. If you have two logs being added, then you combine the two logs into one, where you multiply the expressions or the inputs for each log. And then once you do that, then you undo the log by doing 2 to the 5th power. So you convert it from exponential, so log form to exponential form. Then solve like you usually would, and make sure whatever answers you get when you throw it back into the original equation, that you're only logging positive numbers. You can't log negative numbers. And just be careful, because even if the answer is negative, it may still work. Sometimes a positive value may not work, right? So you got to be careful and just make sure the inside stays positive. For 4, move the 4 over, then divide 2, then undo the log, and you should be fine after that. And you should, of course, you should know your fraction exponents. For 5 and 6, more power stuff, more exponential equations. Try to find common bases. For 36 and 216, 6 is a common base because 6 squares 36, 6 cubes 216. For 6, 2 is going to be your common base. So 2 to the 9th power is kind of crazy. 2 to the -3, 2 to the -6, and 2 to the -3. Use properties of exponents to combine stuff. Like you raise a power to a power, you multiply the exponents. If you have two powers of the same base, but they're being multiplied, you add the exponents and so forth. So you should know all that stuff. 7 and 8, more log stuff. If you have a number out in front, roll to the back, it becomes an exponent, and then treat it correctly. You should be okay there. Because you have one log on each side. For 8, you have a minus between two logs to make it a division problem. And then you treat it like a rational equation, solve that. That should be fine. That's cross multiplying. 9 and 10, just more of the same stuff as before. All's good there. Those are the answers. 11 and 12, again, just rinse and repeat. Just check the answers for logs, because make sure you're not logging negative numbers. Fine, 13 and 14 is just old stuff. I think we did trig in the beginning of this semester. My memory is really fuzzy now. Did we do trig? Like,
Yeah.
in the beginning. Yes, we did do some trig ends. Yes. Final exam. Let's talk about that, because oh, you're here. I say you're not here. Yeah. Just say we're in the bathroom. I was paying attention. How's your? Yeah, no test today, right? Like, well, you can't. Yeah. I'm a softie. That comes that stuff, right? Let's say you're 20 minutes late and you live just a mile from the school. He's not paying attention, is he? Okay. Alex, we're talking about you.
Huh? No, it's not like that.
Oh, okay.
Was late. No,
No, I told you yesterday. Because you're 20 minutes late, but don't you live close to the school?
you're 20 minutes late.
Yeah.
No, but that was because like
I'm just teasing you. I'm giving you a hard time. Don't.
No, but seriously, I was. But it was because like, your house had like construction, right? Like,
Okay. First world problem. Okay. Go ahead. Construction, yes. I like that. Oh, okay.
Not that way.
Okay. Oh, okay. Okay. But you could have maybe called Uber, or I'll give you my number. I'll pick you up about that. Okay. All right. Okay. That's funny. I like this. This is a funny conversation. Anyway, here we go. So work on the more complicated side, right? Anything that's not sine or cosine, make it sine or cosine. That's usually the good rule of thumb. And then use more identities like, hey, I got a Pythagorean trig identity I could use for 1 minus sine squared x is cosine squared x. And then keep flipping it, whatever you got to do. 14 is a bit debatable which side's more complicated. I guess you could work on the right side, perhaps. Combine things. Actually, that is probably better to work on the right side because it's easier to combine stuff than decompose stuff. Because 14, I think I would have a little hard time understanding how to break that apart. Actually, I think you could do it. You can make tan squared, sine squared, but cosine squared. I don't know, actually. I'm a little confused. Right side is easier. Just do that. You get it to match up. So anyway, final exams. The plan is this. So I think it's going to be 2 parts, non-calc and a calc. So we're going to do it just during a normal school day. So it'll be on the 21st, we'll do part 1. On the 22nd, we do part 2. And then that's it. We're done. And the juniors, we'll meet on Friday. The seniors won't be because you guys are getting ready for graduation. But yeah, it's just gonna be the 21st, 22nd. And because this is not, even though this class has more seniors than juniors, overall, this is not actually a junior class, not a senior class. So we can't do the that condition, like, oh, if you get like an A before the final. So we can't do that, unfortunately. I don't have that authority to do that. So senior only courses, sometimes we have this stipulation that like if you have an A going into the final exam, you're exempt from the final. Yeah, sorry, I kind of glossed over that. But this is not a senior only course, so we can't do that. I would get in trouble if I offer that to you guys. But the juniors, you get a final exam out of the way early, right? The juniors get a final exam out of the way early, which is good. Because in the week of finals, like you'll have a free F period on the 29th. So yeah, okay. Was it multiple choice?
Yeah.
It was? Oh.
Part of it.
I don't know. First part. I'm following the lead of Mrs. Sasui because she teaches most of these classes, so I don't know. Maybe I don't know. All right, you're welcome. Good luck, guys. Anyway, let's get going to the lesson today. All right, here we go. And I'm recording the lesson so you guys can watch it later, Tammy and Luke. Good luck in baseball, and hopefully you guys win. All right. So let's get going to notes. Notes are really short again. And then after that, we'll do the quiz, and then you can do homework after that. Okay. And the quiz, actually, I'll show you what some of the quiz questions will look like, so you guys have an idea what to expect. So here, 3 to the x equals 75, right, guys? Quiet, please. So 3 to x equals 75. What I would do is I'd rewrite as a log. I write like this. And then I would, oh, this is leaving an exact form. Then there we go. Then we're good. So don't use a calculator because we want exact form. Oh, you need notes. Yes, that's right. These are a new set of notes. Sorry about that. Now, here we go. This is for Friday also. Okay, for example 2, same thing. 2x minus 5 equals log base 1/3 of 120. We can't evaluate that because that's just so weird. Like 1/3 is 3 to the negative 1 power, but 120 is not really a power of 3. That's not, it's kind of weird. So I'll just leave it like that, then add the 5 over. And divide the 2. And there you go. Those are examples 1 and 2. So again, when you're asked for exact form, we're not using a calculator to evaluate. We just have to get x by itself. Any equation, right, for that matter. Always get x by itself. But you have to understand, how do I go from exponential form to logarithmic form? Remember, if x is your input, you want to make it output, and you better make that base to the power of the base of the log. Right? This is how we switch it, right? We should know to be very comfortable with this, very fluid. This is the whole essence of this unit, right? It's going from exponential logarithmic form. Well, here, if that's your base for the x for the power, it's the base of the log. If that's the output, that's the input. If that was the input, now that's the output. Right? Everything switches because they're inverses, as they should be. This right here, I'll just kind of tuck it in. X equals log base e of 158. But what's log base e really? ln, right? I mean, if you write log base e, that's fine. I don't care. But, ln's how it shows up in a calculator, or just so you know. So x equals ln of 158. And I actually do need space for example 4. So again, x equals natural log of 158. Now here, move the 79 over first, which is 166. And 4x equals natural log of 166. And x is natural log of 166 all over 4. We're okay there? All's good? Okay. Yeah, go ahead. Hmm? I'm sorry. Oh, so hold on. We had 2x minus 5. Let me write it first because I want to make sure I follow your question. Base 1/3. Okay, and then we added 5, right? You got it wherever you want. Yes, you move from left to right, of course, right? Yeah, you mean is that what you mean? Of course not. No way. No, well, think about it. It's order of operations. A log is like an exponent. You can't bypass exponents and add before exponents, right? PEMDAS, right? The E comes for the A. Yeah, right. It's part of the input. It's part of the log. No, there's no way I could add 5 to that. That'd be crazy. Because if you had log base 2, let's say I had log base 2/8. Let's say I had this here, x plus 4. I mean, I know it's x plus 4 equals 3 and x equals -1. I can't subtract the 4 to the 8. I can't say this. Then I'll get a different answer. I'll get 2. Right? Right, of course, right. Exactly. All right. Second page. Now, when this happens, what I would do is I take the log of both sides. And this because I'm doing a common log. You can do natural log or any log for any base for that matter. But why am I doing that? Because I want to move this exponent to the front. So it's going to become x minus 5 parentheses times log 13 equals 5x plus, 5x plus 6 parentheses times log 17. Then we distribute. A little messy here because they want an exact form. So I'm going to move this to the left side and move this to the right side. So then these would cancel and those would cancel. So now you got this. Yes, you could convert to decimals, but we want to keep things in exact form because instructions said so.
Did you not just get the,
What do you mean by cancel before?
you just switch the groups?
I did a little switch between 5 log 13 and 5x log 17.
What if it's just-
No, because I had to distribute first. Right? I distributed first. Well, let me back up a little bit. Let me not back up. Let me explain what I'm doing. Okay, let's back up a little. Well, not back up. Let me just explain. All right, so I deliberately log both sides. By doing that, enable to use a log property, which is a power property, by moving the exponents to the front. But we know this way. We know this property did last week. Then here, what I decided, instead of actually getting a decimal, you could just type log 13 in the calculator, give us an acid decimal and distribute it. But because the question asked for exact form, I decided to distribute log 13 as is. So x log 13 minus 5 log 13. 5x log 17, 6 log 17. Then what I decided to do is anything that had an x, I moved to the left side. So 5x log 17, I moved to the left side. So I subtracted both sides by 5x log 17. Right, I did the same treatment on each side, but these cancel out because they're inverses of each other. And then here I decided to add 5 log 13 to anything that's not x and move to the right side. So if that was negative 5 log 13, I added 5 log 13. So I added to this. So I was just trying to be more detailed. Maybe that was a little more confusing. Maybe I shouldn't have done that. Maybe I should just let me erase that so it's not confusing. Let me just do that, if that helps. So then this comes over here and that goes over there. Does that make more sense? Yeah, okay.
Where would they be?
It's not canceled. I factor on x from here.
Oh. Okay.
Then lastly, there you go. We're okay? It's good? All right. And then lastly, what do we got down here? Again, exact form. So you can see that these still involve logs, so we're doing logs along the way. I'd multiply both sides by 9/4. Get rid of that fraction. What's 120 divided by 4? 32. That's 288.
Wait, 120, oh, 180.
Yeah, because I did 120 divided by 4, right?
I thought you said 120.
No worries. Okay, you see what I'm doing with example 7? By the way, example 6, we're good, right? All's good? Yeah, again, I multiply both sides by 9/4, clean that up on the right side, undid the log, sorry, undid the exponent by making a log, because remember, e is log base e to whatever. You can isolate the exponent, do log base e, which is ln. Move the 3 over, divide by 3, you're done. Same thing here, subtract 11, divide -7. Now when you have the power isolated, then you can do right as a log. 2m minus 1 equals log base 5, 7. 2m equals 1 plus log base 5 of 7. And then m all over 2. And there you go. It says use your calculator to evaluate. It's fine. I know you guys can punch in the calculator. It's totally fine. Okay, we're good? Okay. I'm going to do a little brief review for the quiz. I'm actually going to show you one version of the quiz, and then you'll do the other version. They're very similar. Just so you, and I'll just kind of just gloss over and talk about what to do. Then you can just do it. Homework's pretty simple. It's just this right here. And by the way, we'll have the unit finished, I think, by actually, our test is actually Wednesday next week, guys. Sorry. It's Wednesday next week, not Friday. I lied. It's Wednesday next week. It's May 1st. So we start a new unit. So I need to update Schoology. My apologies. I was wrong about that. Let me fix that right now. There we go. Okay, for the quiz. Just know your logs. So we did a lot of log stuff. Just know how to rewrite from log form to exponential form or exponential form to log form. Like in this case here, you guys should know 10 equals 5 to the x power. Or here,
You have to solve it.
no, just rewrite. Pretty simple, right? Here you're supposed to graph these. I know you guys can graph this. I would suggest you guys start with the parent function. Yeah, like plugging like -1, 0, and 1. And then make adjustments. Like what adjustments would you make to x here? No, subtract 1. You should know this. It's always the opposite. What adjustments would you make to y? Which one do you do apply first, the -3 or the 4? The -3 because PEMDAS. So you multiply these by -3, then add the 4. So in this case, that'd be -3/2 plus 4, -3 plus 4, and -6 plus 4. Okay. Yeah, there you go. The domain's always all real numbers for these. The range is determined by the horizontal asymptote, which is that. That's -2, 2.5. -1, 1. 0, -2. Just like that. Here, I'll give you the equation. You just have to set up. This is a non-calc quiz, so you can use a 4-function calc if you need it. But I'll put it on the board. You guys know what n represents, or k, whatever you want to call it? So how many days in a year? Right, what's your rate? So you put 0.04, right? P is 2. And how much money are you starting with? Yeah, you just set it up. And then here, again, 4-function calculus, so no scientific calculator either. What would this equal? So what would y have to be to make that work? 2, 4, 8, 16, 32. So 6, right? -3, good, right? So, yeah. Okay. I think that is it. And we will start the quiz. And then we get at 2:40. So after the quiz, you can start homework if you want, or if you want to do something else, or you're tired, it's fine too.